Good morning, my lovely kiddos and my future mathematicians. Today we are in 9.2a and we're learning about our first special triangle. Okay, so a special triangle have relationships that we can memorize so we don't have to use the Pythagorean theorem every time. Okay, so this is supposed to be kind of like a shortcut for us. We don't have to use the Pythagorean theorem every single time we see a right triangle. We can recognize some of these special triangles and say, oh, I know how to find this side length. Okay, so the first type of special triangle we're going to talk about is the 45, 45, 90 triangle. Now this type of triangle is named after its angles. Okay, so we have a triangle with a 90-degree angle and two 45-degree angles. Now, in our examples, it's only going to include one 45-degree angle, but we can remember that all angles of a triangle add up to 180. So if we were to take 45 plus 90 and plus the unknown angle, or that x, set it equal to 180, subtract over what we know, and we would find that that missing angle, or that x, would also be 45. Okay? Now, some cool things about a 45, 45, 90 triangle is that its legs are equal. Remember that the legs are the two sides that touch this 90-degree angle, or that help form this 90-degree angle. And our hypotenuse, or our longest side, the side that does not touch our 90-degree angle, is whatever the leg length is times root 2, or the square root of 2. All right, so just to show you guys, let's say that our leg length here is 1. Again, notice that our legs are equal. And we want to prove that our hypotenuse, our longest side, is root 2. So the way that we're going to do that is through the Pythagorean theorem. Just a little proof here. So we have our a squared plus b squared is equal to c squared. We want to solve for our hypotenuse. We want to solve to prove that this is the square root of 2. And then a and b are our legs, which we know to be 1. So we're going to plug in our legs and solve for our hypotenuse. 1 times 1 gives us 1. 1 times 1 gives us 1. 1 plus 1 gives us 2. And that tells us what our hypotenuse squared is. But we want to know what our hypotenuse is. And we learned on Monday that if we take the square root, it will cancel out the square, leaving us with just what's underneath, or that's c. So our hypotenuse is, in fact, root 2. Okay? Now it's important to know, and I'm going to make a little star here, that if we are going from our legs to our hypotenuse, we are going to multiply by root 2. But if we're going to go backwards, if we're going to switch it up and go from a hypotenuse to our leg length, then we are going to have to divide by root 2. And that's where some of our struggles are going to come in today. All right, so let's dive right into our examples. Our first one here, we have our 90-degree angle, and one of the other angles is 45 degrees. So we know this is a 45, 45, 90 triangle. One of our legs is 5, the other one is y, and then our hypotenuse is x. Okay, remember that our legs are always equal in a 45, 45, 90 triangle. So we know that the other leg, y, is equal to 5, the leg. Okay? And then to get our hypotenuse, we're simply going to take the leg length and multiply it by root 2, getting 5 root 2. All right? Well, what if our legs already have a root in them? So let's explore that option. All right, so again, we have our 90-degree angle, and one of our angles is 45 degrees, so we know that this is a 45, 45, 90, where one of our legs is 4 root 2, the other one is n, and our hypotenuse is m. Again, since we're starting with the leg, it'd be easier to find the other leg first. So we know that n is equal to our first leg, that 4 root 2. And then once again, going for our hypotenuse, we would take our leg length, which is 4 root 2, and multiply root 2 once again. And this looks like what we did on Monday. So we would take our coefficients and multiply them. 4 times 1 gives us 4. And then we would keep our radical and then multiply the two things under the radicals. So 2 times 2 gives us 4. Now we could make the tiniest little factor tree here and know that 2 times 2 gives us 4. And since we have a pair, we can pull it out of the radical. So we would keep our existing coefficient and then multiply that by the thing that we could pull out, the 2's here. And 4 times 2 gives us 8. So our hypotenuse is 8. All right. We have 3 more for us today. So the first one, we have our 90-degree angle, and one of our angles is 45 degrees. So we know that we have a 45, 45, 90 triangle. We have a length of 14, a length of y, and a length of x. Again, we can identify that y is one of our legs because it is touching or help forming that right angle, that 90-degree angle. And that 14 is our other leg. Since these have to be equal because it's a 45, 45, 90 triangle, I wrote the wrong number. Y is equal to 14, not 15. Okay, and then to find our hypotenuse here, we would take our leg length of 14 and multiply it by root 2. Okay, and get 14 root 2. So our next one here, we once again have our 90-degree angle, and one of the angles is 45 degrees. So we know we have a 45, 45, 90 triangle where we have the lengths x, y, and 12 root 2. Okay, so here we can see that both of our legs are the unknowns here because these are the two sides that help form this 90-degree angle. So we know our hypotenuse, so we're moving from hypotenuse to legs, meaning we are going to have to divide by root 2. Okay, so looking at x and y, because they are equal because they're both the legs, we have our length of 12 root 2, and we are going to divide by root 2. But radicals cannot stay in the denominator, so we are going to have to do something called rationalize the denominator by multiplying by a very fancy 1, root 2 over root 2. 12 times root 2 is going to give us 12 root 4. And root 2 times root 2, or root 2 squared, is going to cancel out that root and just leave us with 2. Now, once again, we can do our smallest factor tree, pull out that 2. I'm going to move down here. So we have 12 times that 2 divided by 2, 24 divided by 2, or 12. We could have also spotted that in the previous example, we added a root 2 onto our side length, and we could have seen that this root 2 was just added onto our side length of 12. All right, and then our final example here today. We have another 90-degree angle, and another one of our angles is 45 degrees, so we know that this is a 45, 45, 90 triangle. We have the lengths of y, x, and 15. We can once again see that our legs are the unknowns here, so we are once again moving from hypotenuse to legs, so we are going to have to divide by root 2. So we take 15 and we divide it by root 2, and we run into that same issue where we cannot have a radical in the denominator. So we are going to have to multiply by our fancy 1, root 2 over root 2. Okay, 15 times root 2 is simply 15 root 2. And again, root 2 times root 2, or root 2 squared. That squared cancels out the square root, just leaving us with that 2. Okay, keep in mind that I do want you guys to rationalize the denominator. If you tell me this, even though it is technically correct, I will have to take points off because it is not rationalized.